Hey, so in this video we are going to show that the integral of secant x is the natural log of secant x plus tangent x. So in a typical class, you'll know, so we know, let's say, that the integral of secant squared x dx, all right, we know that one, and we also know the integral of secant x tan x dx. All right, so if we know those two things, we can kind of make our original function, this one, secant x, we can make it look more like one or both of these functions, right? So let's just assume that we could have this secant squared x and this secant x tan x, and they were added together. Let's say we wanted to kind of add these integrals. Secant squared x dx plus the integral of secant x tan x dx, and we could actually just integrate the whole thing, secant squared x plus secant x tan x dx. All right, and we know how to do that. So what we're going to do is come back to our original problem and make it look more like this problem here, secant squared plus secant x tan x. So let's go to my black pen, and here we're going to start the problem back. So the integral of secant x dx, let's go ahead and take that and multiply by, let's see, secant x. Let's multiply by secant x plus tan x. Maybe I wasn't clear. Up here, we're going to say integral secant x, parentheses, secant x plus tangent x. So we also know how to integrate this now. Okay, because if we distributed it through, then it's just exactly this. We started with two integrals that we could integrate. We kind of added them together, and then we just factored out a secant x. So now, starting here, I'm going to have secant x, and what I want to do is just multiply it by secant x plus tangent x. And if I multiply on the top of a fraction, then I also need to multiply on the bottom, so that's secant x plus tangent x on the denominator, so dx. All right, so from here, we might be a little bit stuck unless we know something called u substitution, and thankfully we do at this point. So u equals secant x plus tangent x, and the derivative of each one of those, the derivative of secant x is actually secant x tan x, and the derivative of tangent x is secant squared x. Okay, so actually when I distribute the secant through the numerator, that gives me secant squared x plus secant x tangent x, which is really, really good news for those of you who know how to do, who are very comfortable with u substitution. The reason that's good news is because you want this part, I forgot to write dx, but you want this part to match up exactly with the numerator. And it does, secant squared x plus secant tan x dx. They match up exactly. So instead of writing all of this in the numerator, I'm just going to be able to write du. And instead of writing the denominator, I just need to write u. So here we go. Integral 1 over u du, which would then give us the natural log of u plus a constant. Well, u was secant x plus tan x, so natural log secant x plus tan x. And we have effectively shown that secant x, the integral of secant x is equal to the natural log secant x plus tan x plus c. All right, so I hope you enjoyed.